Hello and welcome to the section 6.2 lecture today for Algebra 1 Part 2. And in today's lecture, we're going to start talking about converting line forms. So going from one equation of a line to another. Basically, it's going to turn out to be just solve the equation for the kind of variables or variable that you would like to see. So we're going to talk about four main conversions today. We're going to go from point slope to slope intercept. We kind of talked about that yesterday, so that'll just be kind of a quick movement there. Point slope to standard form, and then slope intercept to standard form, and standard form to slope intercept. So we're going to mainly focus on kind of what our end goal is, and then look at the various given equations. So for starters here, we're going to work towards slope intercept form, okay, from point slope form. I guess and from standard form as well. But I just want to think about what is my end goal with an equation like this. If I'm trying to get to slope intercept form, the key thing is that is y equals mx plus b. So the key there is that it's solved for y. And so if I want to solve this one for y, and again, I did this yesterday, but I'll do it again. I really want to distribute first, and then I want to add y to both sides. And that y will probably get added to the mx1. And then that'll have an x term, slope times x. And then all that together will give us our b, is the idea there. From standard form, still trying to solve it for y, I'm going to subtract ax from both sides. And that could turn out to be okay. It could be painful, but we'll see. Actually, no, I'm guaranteeing these two aren't going to combine. Sorry, I wasn't thinking too much. So I'm going to write it the way that we would probably want to see it. We're going to say that it's minus ax plus c. Remember, in standard form, c is a constant. It's just a number, but this term does have an x with it. Then I'm going to divide by b, and I'm going to divide each piece by b to give me y equals negative a over b x plus c over b. And now you could use these little shortcuts here, these little kind of formulas that we've created, but that would be a lot of memorizing, kind of like the standard form, finding the intercepts. The x-intercept is at c over a, and the y-intercept is at c over b. That's kind of tough to memorize versus just realize what you're looking at and what you want to do with that equation. So, excuse me. All right. The key behind these is that we really just want to solve them for y, and once we solve them for y, we're good to go. So I'm going to take a start on this one, and we're going to look at y minus 4 equals 1/2 x plus 3/2. That's about as good as I can say there. And then when I add 4 to both sides, I'm going to be adding 4 to the 3/2. And this is that mx, my negative mx1 plus y. That's what this ends up being. So I get y equals 1/2 x. And then I'll just think about that as 8/2. 4 is 8/2. So we get 3 plus 8, which is 11 halves. Not an awesome equation, but not terrible. Next one. This one, actually, I almost think of as kind of easier. When I'm moving standard form into slope-intercept form, the one thing I have to remember is that this 6x and this negative 12, they don't combine. right? They don't have any, or the 12 doesn't have an x on it, so they don't combine. And so this is what I get. And then I'm going to divide by -3, and I could say that I'm going to divide the whole thing by -3, but that's the same thing as as dividing both the pieces by -3. So I might as well just do that. -6 divided by -3 is +2. Not even going to mess with that negative. So we get 2x. And then -12 divided by -3 is +4. So that's the equation that we get there. Okay. All right, so now I want to move us into standard form. Okay, we want to go from point-slope form and from slope-intercept form. But we want to get into standard form. So the key there is that x and y are on the same side. And I'm going to say that we're going to worry about a and b not being fractions. Okay, so we'll go over that once we get there. But the first thing, or the first goal that I have, is that I want to get x and y on the same side. Okay, for point slope form, it might be a little bit tricky because I'm going to have to start off by distributing. Oops, it's still going to be a minus. It's going to be a minus. Come on. Minus mx1. And now let me be clear about this. Remember that x1 is a point, so mx1 is just a number. Okay, even though there's an x there, I'm not trying to get that on this left-hand side. I'm going to try to move all my numbers, or all my variables, to the left, so it looks just like this. So I'm going to move this over. Minus mx. And so if I put that in front, I have minus mx plus y minus y1 equals negative mx1. Now I just need to move my y1 to the other side. And again, that will combine once they're numbers with that, because they would all just be numbers. And this one's definitely one that I would not recommend trying to memorize the formula here. But let's kind of recap what we did. We distributed, then we moved our x's to the left to be with the y's, and we moved our numbers away from the left. We moved our numbers to the right. That's really all we did. But this one gets very ugly, and weirdly it kind of looks the same, right? That's kind of a weird aspect of that. But one of them has ones, the other one doesn't. So it's just the layout of that one's kind of interesting. And then this one in slope-intercept form, all I need to do to get x and y on the same side is subtract mx from both sides, or move my mx over. So I get negative mx plus y equals b. All right, so then I have x and y on the same side, and that was my goal. Okay, so let's look at this one, or these two, sorry. The first one here, I do want to distribute, so I have y plus 15. And if you wanted to subtract 15 at the same time, you sure could. I'm trying to do it kind of step by step. And then negative 3 times 10 is positive. Sorry, negative 3 times negative 10 is positive 30. I need to move my x over. And I'll go ahead and subtract 15 here. Okay. But moving my x over, I'm going to have 3x plus y. The 15s will cancel. The 3x's will cancel. 30 minus 15 is 15. And that's good to go. Okay. The last check would be, do I have any of my coefficients on the left, either my a or my b? Do I have either one of those that is a fraction? And no, I don't. Okay, no, I don't. Realistically, they're going to be the only numbers that are fractions. And if they were, then we'd have to do something with them. but they're not in this case, so we're good to go. This next one here, and as I talked about up above, I'm just going to subtract the 1/5 x. And that's going to really get me where I want to be. I have negative 1/5 x plus y equals negative 12. So here's an issue that, and I will say that the verdict's kind of out on whether or not this standard form can have fractions or decimals. Some people say yes, it's okay. Some people say no, it's not. There's even some of the older ones that say a can't even be negative, and that's kind of extreme. I'm not going to take it to that level, but I will say that we can deal with the fraction part of it. So how do I get rid of my fractions in this whole equation? I'm going to take the whole thing, really looking at both sides, and multiply it by 5 so that I get rid of this fraction. Okay, I'm going to multiply every piece of this by 5, really big distributive property, and I'm going to get negative x plus 5y equals negative 60. Okay, and that's perfectly okay. Like I said, the only other thing that some people would say, and sometimes I like to do it just to get it out of the way. Some people are going to mess up this leading negative. They don't really like a leading negative. So then they'd multiply it by a negative 5 to make this positive, minus, and positive. But either way, that's okay. I'm not going to put that on there because that'll confuse some people. Yeah, there we go. All right, so hopefully a little bit of that made sense. Really, we're just solving these equations for different things. As long as you can do that and use your solving equation skills, I think you'll be just fine. Anyways, I hope you have a great day, and we'll see you in class.